3DBenchy is done. Actually, you'll see that there are 3 of them. The one that I started printing when I finished that video, I showed you that actually the part had detached, and that is the benchy that is here. It's mostly good, except that the top half here didn't complete because it fell off from the build plate at this point. This is interesting kind of just because this top part here is just so shiny. It has the surface finish of the FEP film, which is pretty nice. This is the benchy that I printed after that. I want to show you the differences as to kind of like what I changed in order to get it to print. The main thing is I increased the attachment layer to hold the part more firmly to the bed. And so while the attachment layer here is a little bit small, and actually it doesn't actually profile here, there's a piece that broke off here, you can see the attachment layer here is much larger, extending behind, and actually a piece broke off here, so it actually extends further back. And in the front of it here, which is the part that fell off the first time, I extended it way out here. And so this is the main difference. You can see that the detail on the benchies is actually quite good. You can see that there's a overhang lettering here, what CT3D.XYZ, and that does come out in the floor. You can see it. Printed another one, this one not with MakerJuice, but with the FunToDo resin, the standard blend. Standard blend is much softer. This actually took a couple of tries to get off. This resin is quite different from the MakerJuice. It prints faster. This one I printed in about 2 hours, maybe 2 hours and 15 minutes. It's much softer, and that makes for some differences. I had a bunch of failures here where the part pulled off the build plate. It fell off basically and failed, and the reason why it fell off is that the soft layer doesn't adhere as well to the build plate, so I needed to make the attachment layer even bigger, and also the material is a bit weaker, and so normally I only use one attachment layer, but if you look closely you may see that there are 3, right? Layer 1, layer 2, which is a little bit smaller, and layer 3, which is a bit smaller than that. And the reason why I needed this is because the part would actually tear off at the seam, right? Because the boat is here. It would tear off at the seam and lose adhesion. So let me quickly just kind of now, you can see how soft this is. Let me get rid of the attachment layer now that we are on camera. There's a little bit of water left from some UV finishing I did. That's why it looks a little wet. Let me dry that off. And then these guys also. This material you can see is much more brittle. It's harder, and it breaks off rather than tearing off. And I would have to I would want to finish this with a knife after breaking off the majority of the portions here. You'll notice from the position of the nut that I did actually move this around. This guy moved to completely avoid the nut in the bottom part. It's just barely off to the side on the attachment layer. This guy's dead center This guy moved it to a slightly different part over here, but you can still see that it came in here. Overall, you can see that the lettering at the bottom, which is 2 layers thick, came out very, very clearly on all of the parts. Yeah, this one here, it came out the least clearly. I'm not exactly sure why. The lettering in the back here is also it's 0.1 millimeters, 100 microns deep. You can see it, but you probably aren't going to make it out that well in the video. I would need to show you in macro. It's because there is some distortion because I did print this in the coarsest possible mode, which means in 100 micron layer thickness. If I had printed with maybe 50 micron layers or 25 micron layers, this might come clearer. But what's interesting here is that you can see it. The XY detail is sufficient that at 100 microns XY, this comes out even though the Z layer height interferes with our ability to see it very clearly. The details do come out. So I can resolve, when I'm printing at 100 microns XYZ, I can resolve a full 100 microns of detail, meaning that some part of the feature does appear, even though since we're at the kind of the minimum resolution, it's not super clear. And then the roof came up. No supports were necessary at all. So we have the overhang. There's a massive 2-dimensional bridge, right, that brings in this roof. No problem with that. No problem with any of the holes here, right? So there's no weird stuff hanging off like I might see with many of my FDM prints. No problem with the holes here. No problem with this little hole, tiny hole way here at the base. That hole also resolves without issue. No issues here. And I don't know if you can see in, but also no problems with the steering wheel that's in there. That looks, that's totally fine. You might be able to see it more clearly with the red. I really do like the way that this red came out really bright. I did pigment this myself with Tap Plastics pigment, red, a little bit of yellow also, just to brighten it up a bit. So we can see here also, all right, the back porthole came out really clean. There's a little water still inside of the little spout in the back, but that also came out well. And the vertical surface here of the steering wheel also came out without issue. These holes also, no problem with the holes. So all of these components here really with the way that this was designed, there's really no challenge at all to an SLA printer. Because I did print it flat, what we'll notice also is that fully flat portions like this surface here, that is totally flat, have really nice smooth surface finish, right? Because the surface finish here is going to roughly be the surface finish of the FEP film. Same thing here on in this square cutout here. The top is also, that's perfectly flat. We do see some stepping because the part actually doesn't contain that many flat portions. And so there is some stair stepping as I go up because I'm using relatively thick 100 micron layers. Similarly, since the wall here is also built up on there's some features here that are on a slight slope. We can see that there are some kind of pixelation artifacts here, and that it's interesting because it means that we're focusing down to the individual pixel level, and so that these artifacts are very apparent. I did not use any anti-aliasing so I don't have the effect of any anti-aliasing going on in any of these models. That might affect the smoothness of the finish, but the detail that's possible here in terms of the resin's capability to hold detail is very, very good, right? At 100 microns, we can get down to resolving individual pixels as features. And now I'm not saying that you can build like a 1 pixel tall pillar. It might not be structural. A single pixel isn't likely to be structural in that way. What that means, however, is that from a feature perspective, when we have features that are a single pixel, they will show up somehow, right, in the model, and that means that if you put patterns that are patterns in a surface, and those are 1 pixel wide, you will see a matching pattern in the print somehow. Yeah, you can see how the difference in hardness from when I tap this compared to when I tap this, because this I think has a Shore D close to 70, whereas the FTD standard has a Shore D of around 30. So you can see, the flexing that I can get here when I squeeze, which isn't to say this is a flexible resin. It's still a bit brittle. It's like both brittle and soft, that if I really squeeze it, it will crack. But you can see that, right? This is totally rigid. And so 3DBenchy's printed at 100 microns on the Kudo3D Titan 1 in MakerJuice G+ Black and in the FunToDo standard blend.